This is a solution video to problem 3.7 from our textbook. This is creating the muffin tin shown in figures 3.7a, b, and c. And there are actually a few different ways you could create this part. I don't know that any one of them stands out as the best way to do it, so I'll go ahead and do it a couple different ways with you just to kind of think through how you might go about it. So I'll start with my inch part template. The first way I'll do it is to create the muffin tin cup as a solid block shape with the outer taper and then shell it out. So I'm going to start on my top plane. I'm going to sketch, looks like the inner diameter of the muffin cup at the top is 3 inches and the wall is 50 thousandths. So the outer dimension would be 3 inches plus 50 thousandths times 2. So that would be 3.1 inches. And then I'm just going to extrude that out. And I'm going to extrude down. And looks like the cup has a depth to the very bottom. It would be 1.55 because the inner depth of the cup is 1.5 inches, and then again the wall thickness on the bottom would be 50 thousandths. So I'm going to extrude out 1.55, and now here I'm going to take advantage of the draft tool to put that 10-degree taper on it. So now I have a cup, or a puck basically, the shape of the cup, and I can just use the shell tool to hollow that out and say 50 thousandths. Okay, so that's probably the fastest way I can think of to create an individual cup. Let's just verify that it all turned out right. The inner dimension, oops, I'm in millimeters. So it's 2 thousandths under. That has to do with the dimension of my taper probably being on a diagonal. So if I really wanted to perfect that, I could go back to my sketch and add 2 thousandths onto my original one. So let's go back, take a look at that sketch, make sure 3.1. So I could 3.102 and go back and see what that ends up with a final inner diameter. So yeah, it's 3 thousandths there. Okay, so now I have a cup. I could create a pattern of those. So linear pattern, directions not along the edge. I can use a plane to give me a direction since I don't have any straight edges out there to select. So we'll say use the front plane for 1. Spacing is 3.5 inches each direction, so 3.5. And then direction 2, I'll use the right plane, and it's also 3.5. Okay, and I have 4 of them. Okay, so here I can pick features and faces, so I could pick just this and it would do the inside. I could pick all the faces, but something that's more useful here is I can pick bodies instead of features and faces. So I just click on that one thing and you can see it grabbed all of it. So let's just look at it from the top so that I make sure I have my orientation how I want. So I'm going to reverse my directions. I'm thinking in my head of the one that I've created as the bottom left. So there we go. I now have a pattern of them and that all looks fine. So I will say OK. So now I have the 12 cups. So I can just sketch on the top face here, sketch on that. And to start with, I need to find the center of this pattern of them. So I can do that a couple ways. One easy way to do that would be to draw a center line from the center of this cup to the center of that cup. And then I can use the midline of that, the midpoint right there. That'll be the center of all of them. So I can do a center rectangle off of that midpoint. Dimension was 14 inches by 10.5. Some radiuses around the edges of, looks like 1 inch. Okay. So now I have the outer shape of the sheet part that's going to be on top. Then I can come in and just copy, so select the inner diameter of one of these shells. I don't want to select the outer one because what I'm going to do is extrude down, and if I select the outer one, that would leave a real fine gap as the sheet went straight down, but the cup tapered in. So I want to make sure I select the inner dimension, and I'm going to convert that entity. Go perpendicular so I can see it again. So you can see now I've got that inner there, and I'm going to do another linear pattern. Again, spacing 3.5. I want 3 of them in that direction. 3.5. And I want 4 of them in that direction. Okay, so I think now I've got a sketch that shows all of the geometry I need to extrude out. So I will do a extruded boss base, flip the direction. You can see it's going up, and I want it to go down towards my cup, and change the thickness to 50 thousandths. Okay, so there we have our muffin tin. That's created one way. You can see the hardest part is creating the cup, and that was a relatively easy way to create the cup, extruding it as a block and then shelling it out. So let's just verify again that we have a 3-inch ID, yep, and the distance from top to bottom of the cup is 1.5 inches. So that looks good. So that's the first way that we could do it. So now let's look at another way we could have created the muffin baking tin. So I'm just going to delete everything that we did so far. Okay, and we'll start from scratch. This time, instead of doing an extrude with draft to create the tapered cup, let's try doing a loft between 2 different section shapes. So again, I'll sketch on my top plane. I'll draw my first one, which it will be the upper dimension. So that will be, I'll draw the 3 inches. And then I will create an offset entity from that for the wall thickness of 50 thousandths. Okay, so that's going to be my first sketch. So I'll come out of that one. And now I'm going to create a plane offset from that. So my bottom surface would be 1.5 inches. Actually, it would be 50 thousandths down from that. So I'll create reference geometry, plane, off of the top, reverse the direction, and say it's 1.05. Okay, and then I'll sketch on that plane. And so here now, I guess actually I don't really have enough information yet to sketch that bottom one, since I don't off the top of my head know what the dimension would be 1.5 inches down at 10 degrees. So I'm going to cancel out of this sketch, and I'm going to create another sketch that helps me figure that out. So on the right plane, I'm going to sketch and just draw. I'm going to bring this into my part. So I'm going to convert the top sketch and change that to construction geometry. And then I'm just going to draw down 1.5 inches vertical, come over and up, and then I can dimension that angle there as 10 degrees. Oops. Okay, and then I'll get out of there. So now I have that sketch to help me when I'm down on this plane to sketch my bottom circle. So now I'll sketch on the bottom circle. On that plane, sketch perpendicular to the top one. Okay, and then here I'm going to rotate so that I can see that this sketch here that I have. I'm going to select that point from my sketch that's just helped me figure out what a 10-degree taper is, and then my current sketch, and I'm going to make them coincident. And that right there gives me the amount of taper there would be in 10 degrees. Okay, one thing I can see that I did wrong there is that that taper is going from the outside to the outside, which would be fine, I guess. I just need to make sure that I make my offset for my next piece to the inside then. Hopefully that makes sense. So I want to reverse it there so that that line is going from outside edge to outside edge. Okay, so now I have two sketches, and I can try lofting between them. So my two profiles are going to be sketch 3 and okay. I'm going to pick the region that I want it to loft, which is that inside there. So that's, I should talk about that here. I can either pick just a shape if I wanted, it would try to loft all inside there. But the one I want, so I actually want a region, I'm saying loft everything that's between there. So that's my first profile. And then my second one will be down here. And again, go to region. Okay. So there I have that now. So let's just right now see what happens when I do that without anything else. And it looks like it gave me a solid shape instead of the hollow shape that I wanted. So, I mean, that's okay. I could just do my loft now, although it's on the inside. You can see that it's not the outside dimension that I wanted. So it made a cut basically inside the shape that I wanted. So let's go back and edit that. Let's see if I can, if it's going to do that, I might as well just have it do the whole solid outside ring. So instead of those sections that are highlighted there, I would want to create just a, okay, that one and that one. Let's try that. Okay, so now it's basically made the same thing as my draft did, the extruded draft before. One thing to note, if I look at it straight on from the right side, look at here. Here is a straight line that goes from the top edge to the bottom edge. You can see my loft doesn't actually do that. It's slightly cupped in here. And I'm kind of glad that happened because I want to show you I can fix that. That's a feature about the loft here. So it is just creating, it's lofting between those two shapes. But you can see what it automatically did. It added this, what is called a guide curve. And that's on, when you have two circular profiles, it doesn't really make a whole lot of sense why it turns out like this. It connects the point from the top here to the bottom. So it's basically rotating the loft as it goes down. So if I bring these closer to vertical, and let's rebuild that, you'll see that that taper becomes less obvious. Or if I make it, if I exacerbate it, let's pull it all the way around to make it really clear what's going on. It'll become, see how much more it's becoming like a hyperboloid basically. So that's called a guide curve, and it automatically added that guide curve. That's actually a reason why I created this sketch here too, is I can force it to follow my curve. So it just goes from the top straight down to the bottom. So if I do that and rebuild it, you'll see now that it's a perfectly straight line from top to bottom at 10 degrees. Okay, so that's what we would want in this case. And from now, we're basically at the same place we were when we did the draft extrude version of this part. Just took a lot longer to do it via loft. So here I could shell this out again, and then just continue on with everything as I did for the first part. Okay, that's one option. Clearly it doesn't work as smoothly, but I just always kind of helpful when I'm doing these solutions to help you guys realize there's lots of different ways you can do things. So let's delete everything again and do one last version. And I would ask you to think about, what do you think, oops, I'm trying to delete it all. What do you think would be a potential solution for creating that individual cup that then we pattern? Hopefully in your mind, to a certain degree, you're thinking that could have been a revolve function, right? The cup is a part or a feature that has symmetry about a central axis. So to do that, I'm going to sketch on a right plane, and I'm just going to sketch a profile section through the cup. So I'll start with a center line that's going to be my axis I revolve about, and then I'm going to create some geometry here that I'm going to just start by creating basically one side of the wall of the cup. And so I know that the inner dimension here is supposed to be 3 inches diameter, and I know that from the top to the bottom is supposed to be 1.5 inches. Oops. And I know that this angle is supposed to be 10 degrees. Okay, so now I've got basically the inner surface of my cup, so I can just offset all these 3 lines the opposite direction, because I drew the inside, so I want that to be outside it by 50 thousandths. That's fine. One little detail to see here, when you're using the offset entities, you can see you can cap the ends. So in this case, that will just save me drawing the lines later. I can cap them, and it defaulted to arcs. So if you zoom in here, it put a little round on the end. That's not what I want. I just want to cap them with lines. Okay, so there, I guess one thing, I'll go ahead and do that, but one thing that's undefined, if you look, my sketch is still a little underdefined because I haven't done anything to define this. And that's because really that's arbitrary, right? That's all going to end up a complete plate later on. But just since we want our sketches to be fully defined, I'll just dimension that right now with saying, let's say 2 inches. Okay, now I can revolve this part. So if I go to Features, Revolved Boss Base, and it picked up my center line there. So there is my cup, and I could then create a pattern of these and continue on with everything else. That cup doesn't look quite the same. Did I get my dimension in there right? Did I do 10 degrees or did I accidentally do something else? Yeah, I did 10 degrees, so it's right. Okay, and 3 inches, everything. Yep, it all looks okay. So I would again just create a feature pattern now, a linear feature pattern, using planes for directions. So you can go 3.54, pick the body that I want. That's this one. Okay, so there is 4, and you can see it looks like maybe I put too much. Maybe actually it's just perfect. How much of a lip I left there. It probably is a little closer than I want, so I'm going to go back and change my sketch just to make that a little less chance that it's going to run over the part next to it. So let's put that as 1.75. That will give me just a 1/4 inch past. Okay, and now let's go do a linear pattern for the cup. Directions will be front plane 3.5 and right plane, and look at it from the top. So I'll reverse my direction, not that one, that one. Okay, and there I have the cups, and I could do just like I did in the original version again to create the plate around them. So hopefully that's helpful as 3 different ways we could create the same part. I think probably the fastest one and cleanest one, simplest one, was the first way I did it, where I extruded a tapered puck, shelled out the inside, created a pattern of that body, and then added the sheet that was going to be the top. Hope that helps.